Hello class, and welcome to the beginning of the videos for the Unit 4-5 flipbook. We're going to be covering 2 units in this flipbook, and there's a lot less for you to have to watch in this particular unit, and we'll spread it out over probably the next 3 or 4 weeks. So before we get into the section that we're going to be covering, I decided to display the titles and the tab headings, so in case we didn't have a chance to see them in class, that you could fill this out now. So go ahead and pause the video. So this is showing on your screen. Go ahead and fill out your title, put your name and your period number on your flipbook, and then fill out the tabs. And once you're ready, then begin to play the video and we'll get to the first section. Alright, I assume that you're done filling out the title and the section tabs, and let's go ahead and go to our first section. This video is going to cover section 5 in your flipbook, the top flap. And the good news about this flap is most of the stuff on this flap is review. But I wanted to put it all together with you in one section now. Basically, this section of your flipbook explains how to graph the 3 different quadratic forms. Now the first one you see up here in the upper left-hand corner, the essential question is, how do I graph a standard form quadratic? And we did that in your quadratic functions flipbook section 3. Let's go over those steps real quick, and then I'll go over the next section, and then we'll pause the video. You can pause the video and write these steps down. Remember, when we graphed a standard form quadratic, the first thing we did was we identified A, B, and C. Remember, a standard form quadratic looks like this. I'll put it up here on the top. It looks like y equals ax squared plus bx plus c. Y equals ax squared plus bx plus c. So next step we do is we'll find the x value of the vertex using this formula, negative b over 2 times a. Remember, the negative b means flip the sign of the b value. Just like we flip the sign of the h value in a vertex form, you flip the sign of the b value and then put that in the numerator, and then 2 times a in the denominator. And that formula will give you the x value of the vertex. The next step is put the vertex, the x value of the vertex, in row 3 of your table. Then fill out the x column with 2 values below the vertex and 2 values above. Then calculate all of the y values in your table, and now you have a table of 5 points on your parabola. You can then plop those 5 points and connect them to form your parabola. And of course, always check, class, if it doesn't look like a parabola, one of the points or more don't look like they fit in a normal parabola shape, go back in the table and find your math mistakes. Okay, let's go to, actually right now if you want to, pause the video, go ahead and write these steps down, and then we'll get to vertex form quadratic. Alright, we're back. Hopefully you've got those steps written down. The next review section is, how do I graph a vertex form quadratic? Let's write this on the bottom. Remember, your vertex form looks like this. Y equals a times x minus h squared plus k. And we went over these steps already in your quadratic functions flipbook section 3, but we'll go over these steps again together. The first thing was identify the vertex with h and k. Comes right out of the equation. Remember, the equation has negative h in it. That means when we pull h out, we flip the sign of h. Put the h and k values in the row 3 of your table of values. Then, just like graphing standard form, fill in the x column with 2 values below the vertex and 2 values above. Calculate all the y values for those x values. Plot the 5 points and connect to form a parabola. Again, if it doesn't look like a normal parabola, if you had to make some kind of a strange curve, or you happen to have like a straight line as part of your parabola, check your table to make sure you did not make any mistakes. Go ahead and pause the video now and write these steps down. Alright, we're done with reviewing how to graph a standard form quadratic and how to graph a vertex form. The new information today is how to graph an intercept form quadratic. So for our essential question, let's write this down here. I'll put this in red. Essential question: how do I graph an intercept form quadratic? Now, we'll be covering this in your notes, but let's go ahead and write down what the intercept form looks like. There's a number of different ways to show intercept form. Your textbook actually shows it differently, but I prefer this form. So an intercept form will look like this. Y equals, there's our value for A, and then we have x minus p times x minus q. And I'll put a little tail on there so we see that's a q and not a 9. So there is our intercept form. So how to graph intercept form. The first thing we have to figure out is the x-intercepts, which we can actually find right from our equation. So I'm going to do an example in a moment, but we're going to find the x-intercepts and put them in rows 1 and 3 of your table. Now take a look at this. The table for graphing intercept form only really needs to have 3 rows instead of 5. The top row and the bottom row will be your x-intercepts. The middle row will be your vertex, and those are the 3 most important parts of your parabola, and we'll be able to find all 3 of those from doing these steps. So you're going to find the x-intercepts, then you're going to find the x value of the vertex and put it in row 2. It tells you how to do that. Add the x-intercepts together and divide by 2. Then we're going to calculate the y value of the vertex, and then we're going to plot all 3 points. So let's go ahead and do an example here. So I'm going to write down a sample quadratic equation in intercept form. Let's go ahead and write this now. It's going to be y equals 2 times x plus 1, parentheses, and then in parentheses next to that, x minus 3. Now we'll be covering in our worksheets in class how to now go about and find the x-intercepts, but I will go through those steps right now. We know that your x-intercepts are always where the value of y equals 0. If you look at your x-axis on your coordinate grid, you'll see that if any point is on the x-axis, the y value of that point has to be 0. So basically what we're doing is we're going to find all the x values that change the y value to 0. So I'm going to write this down. We're going to just say, all right, let's set y equal to 0, and let's find out which x values, how many x values will turn y to 0. Here's the fun part, or the easy part is, it's pretty simple to do. We know, class, that if you multiply any number times 0, it changes to 0. So we can't do anything with the 2. That's a constant, that's set. But take a look at x plus 1. If we can figure out what changes x plus 1 to 0, we can find a value of x that changes the whole equation to 0. It doesn't matter what this is going to be. If this value here, x plus 1, is equal to 0, then our equation is going to be 2 times 0 plus times some other number, and that automatically changes to 0. Well, this math is easy. What is the value of x here? Just subtract 1 from both sides, and you'll end up with x equals -1. There's our first x-intercept. Let's go ahead and find the next one. So let's find out what turns this part of our quadratic to 0. So we'll do x minus 3 equals 0. That's just as easy. Add 3 to both sides and you end up with x equals positive 3. So if x is either -1 or x equals 3, it changes one of these binomials to 0, and anything multiplied by 0 turns the whole thing to 0. So those are our two x-intercepts. Let's go ahead and write them in the table. The first one was -1. Remember, when x is -1, the whole thing changes to 0, so y equals 0. When x equaled 3, same thing happened. The whole equation changes to 0. So that's how we find our x-intercepts. Let's go ahead and plot those now. We got -1, 0 is one x-intercept, and we've got 3, 0 is our other one. All right, we're almost done. Step 2 says, find the x value of the vertex and put it in row 2. And the way we do that is add the x-intercepts together and divide by 2. Now class, take a look at this. You know that the axis of symmetry has to be exactly between these 2 points. It's always exactly between any 2 points that are horizontal. So I can tell you right now, I know the axis of symmetry is right here. And if that's the case, I know that the x value of the vertex has to be on that line. So I know the x value of the vertex has to be 1 because the vertex has to be between these 2 points. The way we figure that out mathematically is we'll just go ahead and add up these 2 x values. So -1 plus 3. We're going to add them together and divide by 2. Take the average. So that ends up being -1 plus 3 is 2. 2 over 2 equals 1, and there you go. You can see that our x value of our vertex is going to be right here on the axis of symmetry, and that value is going to be 1. Now our only other thing now is we have to plug that 1 back into our equation to figure out what the y value is. You can do that with your calculator. You'll just put in your calculator 2 parenthesis 1 plus 1 parenthesis, then open parenthesis again, 1 minus 3 parenthesis. When you put that in your calculator, you're going to get the y value is equal to -8. -8. So we know that our vertex is at 1, -8. So 1, 2, 3, 4, 5, 6, 7, 8. It's right here. Notice it remains on the axis of symmetry. And at this point, class, you can connect your points together to make a parabola. I'm not even going to attempt to do that on the writing tablet. Actually, you know what? Let's just try. I got a couple moments here. Let's just try with a dashed line to see if there's a way that I can do it. I'll try to put some points here so you can see kind of what it looks like. You can go ahead and connect those together on your paper because it's just too hard to actually draw the parabola with this drawing tablet. And there is what the parabola basically looks like. And that is those are all the steps to graph an intercept form quadratic. Find the x-intercepts, put them in your table. We know the y values of those have to be 0. And then find the average of the 2 x-intercepts. That gives you the x value of the vertex. Plug that into your original equation and you'll end up with the y value of your vertex and plot that and connect them to form a parabola.